A square of area 2 is inscribed in a square of area 3, creating 4 congruent triangles as shown below. What is the ratio of the shorter leg to the longer leg in the shaded right triangle? Let's label this. I'll call this x, and I'll call that distance y. So what we are essentially trying to figure out is the ratio of y over x. So that's what we're trying to find. Okay, so let's work with this now. Let's see here. We know that x plus y is going to be equal to root 3, right? Because the large square has an area of 3, so that means each side would be root 3. And then I guess I just square this. X plus y squared would be 3. And then I'll expand it because I'm confident that we're probably going to have to use this, polynomial somehow. Okay, now the next one, this is y also. It's all congruent, right? So that's y and that's x. So if you look at that triangle, because it's a right triangle, x squared plus y squared using Pythagoras would be the hypotenuse, which I believe would be root 2. Root 2 squared. Right, root 2 squared. Because the smaller square has an area of 2, therefore its side would be root 2. Okay, so that obviously is just x plus y squared. X squared plus y squared is 2. Okay, so that is what we're doing so far. And let's see, where can I go from here? I think if I have another polynomial, I've got x plus y. If I have x minus y, that might help. Let's see what that is. That's x squared minus 2xy plus y squared. And I think that will help me. Because now this is x squared plus y squared. And then this is minus 2xy. Okay, I think this will be beneficial. So x minus y squared. X squared plus y squared is 2, so that's 2. And minus 2xy. Okay, xy I can get, because that's what I was initially going to go for. But I'm going to be able to get it now. And that you can get with that equation fairly straightforward. X squared plus 2xy plus y squared is 3, right? Well, x squared plus y squared, that's this guy, that's 2. And then we have 2xy is 3. So 2xy is 1. And therefore xy is a half. And that is what we can put right here. So therefore, x minus y squared is 2 minus 1, so that's just 1. So x minus y, if you take the square root, it'll be 1. And just take the positive 1 because it can't be negative because these are distances. And I think that's it. We have enough. We have that guy, and that should be enough to figure out both x and y and then figure out the ratio. All right, so if I take this equation, that equation, and I add them, I will get 2x is equal to root 3 plus 1. And therefore x is root 3 plus 1 over 2. All right. And then any of these you can use if you want. Doesn't really matter. Which one do I want to use? I'll just use this one. That would be that x minus 1 is equal to y. So if you sub that in, we'll get root 3 plus 1 over 2 minus 1. And therefore y, if you do that math, will be root 3 minus 1 over 2. Okay, so then now we have more than enough to find y over x. Y over x, that's going to be y, which is root 3 minus 1 over 2, over x, which is root 3 plus 1 over 2. And then, you guys can do this, but I guess I'll just do it. This will be root 3 minus 1 over root 3 plus 1. And what are the answer choices here? I think they probably rationalized the denominator or something. Okay, so I got to do all that. Yeah. Okay, so let's rationalize the denominator. So we got root 3 minus 1, root 3 plus 1. So I got to multiply top and bottom by root 3 minus 1, right? Yeah, root 3 minus 1, root 3 minus 1, like that. Okay, so that's going to be 3 minus 2 root 3 plus 1 on the top, and this is going to be 3 minus 1. So that's going to be 4 minus 2 root 3 over 2. And finally, that's 2 minus root 3. So 2 minus root 3 is the answer, and that is C. How many 3-digit positive integers n satisfy the following properties? The n is divisible by 7, and the number formed by reversing the digits is divisible by 5. Well, we have divisibility rules for many numbers, but the one for 7 is kind of interesting. It basically states that if you have some number, and let's say it's ABC, like a 3-digit number, if you take the first 2 digits and then subtract from it 2 times the third digit, you'll get a multiple of 7. So for example, you have 147, right? If you take the first 2 digits, which are 1, 4, and subtract from it 2 times the third digit, you will get actually 0 in this case, which technically is a multiple of 7, right? 7 times 0. A little bit more interesting would be 154, which is if you take the first 2 digits and subtract from it 2 times the third digit, you get 15 minus h, which is 7, and that's 7 times 1. So that's probably a little bit more interesting. So that's a strange divisibility rule, but that's how I'm hoping that's what we're going to use. Let's see. The first thing I'm going to tackle is this guy. If our number is ABC and we reverse it, it becomes CBA. And they're saying that this CBA is divisible by 5. So that for sure means that the A is either a 0 or a 5. Now, the A could not be 0 because if it was 0, then that original number would not have 3 digits. It would be a 2-digit number at best. So I'm confident that the A is 5. So this is really a 5BC, and the reverse is CB5. Okay, so that's all we can get from that one. Now we need to concentrate on that one there. Okay, so I guess we will use the divisibility rule that our CB minus... Oh wait, the divisibility rule applies to the original number. Okay. So it applies to this guy here. Okay, I gotta make sure I do it on the right number. So that means AB minus 2C is equal to some multiple of 7. All right, let me just see if I did that correctly. Yeah. Okay, now we have concluded that A was 5, so that's really 5B minus 2C is equal to 7K. Now, I gotta be careful here because this might be a little confusing. It's not 5 times B, it's just the digits. See, just like that. I hope you understand what I mean. Like, this is representing a 15. It's not representing 1 times 5. I know it's a little confusing, but hopefully you guys understand. Okay, so basically what we want is we want integer solutions to this equation. And n, well, n is ABC, and we had concluded that it starts with a 5. So n is anywhere from 500 to 599. So what we really are looking for is some number in that range. And to be honest with you, I don't really even see a use for that. I guess all I have to do is just figure out what numbers are in this range that are divisible by 7. And that should be fairly easy. Because if you divide 500 by 7, you'll see it's like, 71 probably. So, and then when you multiply that by 7, you get 497. I think 71 times 7, I think. Well, we just got to keep adding 7s. So the next one would be 504, 511, 518, and so on. And then eventually you'll get to the largest one, 595, and then eventually you'll get to 602. So we're just looking at these guys. And if you count them all, you will see that there's 14 of them. So yeah, if B is the answer. So interestingly, I didn't even need this divisibility rule. I just could just figure out that A was 5, and then that's it. Just jump to this right here. Abdul and Chiang are standing 48 feet apart in a field. Bharat is standing in the same field as far from Abdul as possible, so that the angle formed by his lines of sight to Abdul and Chiang measures 60 degrees. What is the square of the distance in feet between Abdul and Bharat? Let's draw the diagram. I think the proper interpretation of the diagram is like this. So, for example, if this is Abdul and this is Chiang, this is Bharat here. So the angle 60 is this guy. So that is the angle. And this angle, I don't know, so I'll call theta. And those two are 48 apart, and I'll call this guy x, that hypotenuse. Okay. So I think the sine law will help. So sine of 60 over 48 will be equivalent to the sine of theta over x. So that means, well, this is root 3 over 2 over 48. So those numbers I know. And let's see here. I think I'm trying to isolate for x, right? What is the square of the distance between Abdul and Bharat? So x, we're trying to find x. We're trying to find x or x squared. What is the square of the distance? So I guess we're trying to find x squared, correct? Okay, so let's isolate for x first, and when we do, it'll be sine of theta times 96 over root 3. And if we are, let me see here, as far as possible, so we're trying to maximize x. So maximize x. So that, well, this is already 96 over root 3, it can't be changed. So I guess we have to maximize sine to maximize x. Now sine, we all know, is between -1 and 1. So the maximum value of sine would be 1. So I guess that's it. Just put a 1 there and 96 over root 3. And then, of course, we want the square, and that's important to actually, well, none of the answer choices are 96 over root 3 anyways. So you'd have to sort of go back to the question to figure out, even if you were initially confused. But you'd have to square this, so that'd be 96 squared over 3, and that's going to be 3072. So that would be C. A number is chosen at random from among the first 100 positive integers, and a positive integer divisor of that number is then chosen at random. What is the probability that the chosen divisor is divisible by 11? All right, let's try to understand this question first before we tackle it. So let's say we've got this range between 1 and 100. Let's say you choose a number at random. So let's say I chose 22. Then let's list its divisors. The divisors of 22 are 22, 11, 2, and 1. Now, the probability that a divisor is divisible by 11, well, how many of these divisors are divisible by 11? This one is and this one is. So 2 of the 4, which is a half, basically. So if I were to choose 22, the probability that a divisor is divisible by 11 is a half. So what they're saying is you're choosing a number at random. Okay, so what is the probability if you choose a number at random that the divisor is divisible by 11? Okay, I got it. Okay, so well, the only time that any divisor will be divisible by 11 is if the number itself is divisible by 11. You see how 22 was divisible by 11. If I chose 13, 13's divisors are 13 and 1, and neither of these guys are divisible by 11. So the number itself has to be divisible by 11. So first let's just talk about which numbers are divisible by 11. And of course, they're multiples of 11. And we'll just list those up until this range. So 88 and then 99, of course. Okay, so let's figure this out. And I think you'll be able to do this pretty quickly because I know it might seem a bit time consuming. But 11, the divisors are 11 and 1. And the probability that the probability that a divisor is divisible by 11 here is a half, because there's 2 divisors and only one of them is divisible by 11. Well, 22 I already did over here, and that was a half. 33, I'll just do 33, and then you hopefully be able to do the rest on your own. 33, the divisors are 1, 3, 11, and 33. And of the 4, only 2 are divisible by 11, therefore that is a half. And you'll see, similarly, all of these guys have a half as the answer to our question. So, how do we figure out the whole thing? Well, what we did is first we choose these nine numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, out of the 100 numbers of the original range. So that's 9 out of 100. That's the initial sort of probability. And then the probability of a divisor being divisible, that's confusing, by 11 seems to be a half for all of them. So you're going to take that 9 over 100 and then multiply by that half, and that would be 9 over 200. And that, I believe, is choice B. An even number of circles are nested starting with a radius of 1 and increasing by 1 each time, all sharing a common point. The region between every other circle is shaded, starting with the region inside the circle of radius 2, but outside the radius of circle of radius 1. An example showing 8 circles is displayed below. What is the least number of circles needed to make the total shaded area at least 2023 pi? Well, if you look at the, let's use red here. If I look at this circle here, and in particular, if I try to calculate that shaded area, it's basically the area of the bigger circle, which would be pi 2 squared, minus the area of the smaller circle, which would be pi 1 squared. And I believe that is correct. And then very similarly, if I want to calculate the next shaded region, that would be pi 4 squared minus pi 3 squared, I believe. And then similarly, it would be pi 6 squared minus pi 5 squared, and then pi 8 squared minus pi 7 squared. So if you add these all up, factor out the pi, you'll basically get 4 minus 1 plus, 16 minus 9, plus 36 minus 25, and then plus 64 minus 7. Not 7, 49. Yeah. And then therefore pi would be, it would be pi times 3 plus 7 plus 11 plus 15. Correct? Now, I want to make sure that this is not confusing. Each of these numbers, I'm going to denote. So this number was denoting this region here, 1, and this is region 2, region 3, region 4. So that's what I mean by the N, region. So that 3 is 1, 2, 3, 4. I just want to make sure we understand it. Now, keep in mind, though, that 3 was calculated by subtracting 2 circles. So that's 2 circles. That's very important. Now, when we get to this point, we've talked about 4 circles. By this point, it's 6 circles, and by this point, it's a full 8 circles. So that you got to understand that. Okay, now where do we go from here? Now, there is a longer way of doing this, which involves the fact that this is just an arithmetic sequence. As you can deduce, it'll go up by 4 every time. So 3, 7, 11, 15, 19. And that's a perfectly valid way of doing it, but it's a little time consuming. So what I would do is I would just use the answer choices, these guys, and I will explain how. First of all, this, if you look at the terms, these guys, I want to get sort of a general term. And it wouldn't take that long for me to figure out that the general term for these guys, not including the pi, and just the numbers, is 3 plus 4 times n minus 1, right? And this is the n right here. So for example, when n was 4, it would be 3 times 4, which is 12, plus 3, which is 15. So it all works out. I mean, you can see that. So we want to essentially extrapolate this guy right here. So 3 plus 4 times n minus 1. And we want to figure out for how many circles and for what n. Now, and that's why I said use the answer choices. These answer choices represent the number of circles. So we really just have to do this about 5 times. Now, I'm going to do it backwards because I know their answer already. I'm going to start with this guy. So if the number of circles was, say, 64, the regions are 32, correct? That's because each region involves 2 circles. So then let's see if I put n as 32 into this guy, and let's see what I get. 3 plus 4 times 32 minus 1 is 127. Okay, now you might say, well, how does that help me? Well, that makes me think that this would just have continued 7, 11, 15, 19, all the way to 127. Now let's see if when you add that all up, does it exceed that 2023 pi, which is what they want me to, at least get to. Okay, so it'd basically be a 3 plus a 7 plus an 11 plus a 15, all the way till 127. And this is where that formula comes in, adding the terms of an arithmetic sequence. And some of you may remember the formula. It's n over 2 times 2a plus n minus 1d. So I'll explain. The n is how many terms, and in our case, our n is 32. A refers to the first term. In our case, it's 3. And we have n again, so 32 minus 1. And d is the common difference, and the common difference is 4. Right? 3, 7, 11. And then when you, let me just see if I did this right. 32 over 2, 2 times 3, 32 minus 1, 10. Yeah, when you calculate all this, it's 2080. And that is indeed greater than 2023. Now, notice I didn't put in the pi because the pi is there. I just, because I know whatever I put in terms of the numbers, I can just stick the pi at the end. So yes, this works out for 64, and you'll notice that it will not work out for the other ones, but there's only one answer choice that's correct, so it has to be E. In a table tennis tournament, every participant played every other participant exactly once. Although there were twice as many right-handed players as left-handed players, the number of games won by left-handed players was 40% more than the number of games won by right-handed players. There were no ties and no ambidextrous players. What is the total number of games played? Ambidextrous is somebody that can use both their left hand and right hand. Okay. Well, let's see, right hand, left hand, so 2x and x, right, if you interpret the question. And the number of games won, that I don't know, so I'll just call this A, and then therefore this would be, let me think about this, 40% more, so 1.4A. So the total games won would be that A plus that 1.4A. So that'd be 2.48. And in terms of a fraction, that's 12 over 5, correct? Yeah. So, or you can write this as 12a over 5 or whatever. So that means that the total number of games won is a multiple of 12, right? Yeah. So multiple of 12. Now, if the look again, just like the previous question, look at the answer choices. This is not a multiple of 12. That is. That's not a multiple of 12. That is, and that is not. So I immediately narrowed it down to 2. Okay. Now where do I go from here? Well, one thing's for sure, that if every participant played every other participant exactly once, if you take, if there's, say, n players, n total players, the number of games would be from n choose 2, right? Because every participant played every other participant. And therefore this is n factorial over n minus 2 factorial over 2 factorial, and that simplifies to just n times n minus 1 over 2. So let's see. That would basically represent the total number of games. And let's see if that can satisfy either 36 or 48. If n times n minus 1 over 2 equals 36, then that means n times n minus 1 would be 72, and therefore n, just by inspection, I'm certainly not going to do a quadratic. It's like, this is 72 is 9 times 8, right? So n would be 9. And if we did the same thing for the other answer choice, which is 48, it would be n times n minus 1 is 96, and there's no integer value of n that would satisfy that. So we have proven that 36, which is answer choice B, is the correct answer. Let ABCD be a rectangle with AB is 30, BC is 28. Point P and Q lie on BC and CD respectively, so that all sides ABP, PCQ, and QDA have integer lengths. What is the perimeter of APQ? Let's make a diagram. So we have A, B, C, D, and somewhere we got to put a P, so let's just put the P there. And this is not going to be drawn to scale. Q, and then we've got to connect them, so there's that one and there's that one. Okay, and then now let's try to understand what it is that they're asking for. So let's label this though. That's 30 and that's 28. And then ABP, okay, that triangle, which is obviously a right triangle. PCQ, PCQ, also a right triangle. And QDA, QDA, also a right triangle. Okay, 3 right triangles, all have integer side lengths, and then eventually we're going to calculate the perimeter of APQ, which is the middle triangle. Okay, so since they're all Pythagorean, we're going to just try Pythagorean triples. Pythagorean triples. So the most basic one that everybody knows is 3, 4, 5. And then you just have multiples of those guys. Multiply by 2, multiply by 3. This original one, multiply by 3. And then so on. So let me list a few of them, and let's see if I can fit any of them. And that's pretty much all this is sort of a mix and match, try to put the pieces of the puzzle together type of question. Because I don't see, I mean, I'm tempted to kind of label it and do equations, but I think that would be unnecessarily time consuming. Okay, let's figure this out. So I'm starting, these numbers are what sort of I have to work with. So let's see if any of those numbers appear anywhere here. The 30 appears here, so let's see if I can use that. Oh, but that's not a oh boy, that's not a hypotenuse though. 16. The 28 appears here, and this is, okay, that's a little bit better. So that could be a 35, and then that could be a 21. Okay, that's good. And then since that's 21, and the whole side is 30, then that's 12. And then the 12 appears here, so that could be a 9, that could be 15. Okay, that's very nice. And then I guess since that is 9, and therefore since the whole side is 28, that would be 28 minus 9, which is what? Oh, sorry, did I do this correctly? I'm sorry, I think I messed this up a little bit. Let me just see here. This should have been, this is 21, right? So the whole side is 30, so that's 9 there, and therefore the 12 would go here. Yeah, because we're matching this Pythagorean triple, and therefore that the 15 is correct on the hypotenuse. So since BC is 28, This length from there to there would be 28 minus 12, which is 16. 16 and 30. Well, 16 and 30 is not on there, so I have to do that then. Then AP squared would be 16 squared plus 30 squared, and then therefore AP squared would be 1156, and therefore AP would be 34. Okay, there we go. So a little bit of mixing and matching, and then the perimeter therefore would be 30 plus that 16 plus that 34, and therefore that's 80. Oh, sorry, I did the wrong triangle. Jeez. Perimeter of APQ. Oh, boy. Let me try that again. APQ is this guy right here. APQ. Let's try again. So APQ, that perimeter is 34 plus 35 plus 15, and that's 84. And therefore the answer is A. A rhombic dodecahedron is a solid with 12 congruent rhombus faces. At every vertex, 3 or 4 edges meet. Depending on the vertex, how many vertices have exactly 3 edges meet? All right, I have no idea what this rhombic dodecahedron looks like, but let's say it looks something like this. Now, that dodecahedron, is that 10 sides? I'm not even sure. But what you can see from there is that each edge is the meeting of 2 faces. So each edge meets 2 faces, right? And then another thing you can deduce from that is that each face has 4 edges. Each face has 4 edges. So let's see what we can deduce from that. So we have 12. Oh, they help me. Okay, great. The 12 faces. Okay, that's very helpful. And read the question again. So there's 12 faces, and each of them has 4 edges. So that's a total of 48. But each edge has 2 faces. So we got to divide this by 2. Since each edge is shared by 2 faces. So that means it's 24. So 24 represents the total number of edges. Yeah. Okay. So therefore, if we look at this diagram again, we have to figure out and eventually how many vertices have exactly 3 edges meet. Okay, well, every vertice has either vertices have either 3 edges or vertices have 4 edges. So this diagram, I think, illustrates that. So for example, this vertice right here, this one, has 3 edges meeting it, correct? But this vertice right here, you'll see, has 4 edges meeting it. So I don't know how many of each there are. Let's call this X and let's call this Y. So the total number of edges, therefore, would be 3x plus 4y. And that, we know, has to be that 24. Okay, that's pretty good progress, I think. So now we have to then, I think, just figure out integer solutions to that equation, and we have to do it by inspection since we only have one equation. And let me just first of all see if I did this correctly. I forgot to divide this by 2. Yeah. Wait, hold on. Yeah, because for the same reason, each edge is shared by 2 faces. Yeah. Each edge is shared by 2 faces. Yeah. because this will be, if I didn't divide by 2, I would double count them. So this would be 3x plus 4y is 48. So this is the equation I have to find integer solutions to. Okay, let me just do it by inspection. When x is 1, y would be 12. When x is 2, y would be 9. When x is 8, oh sorry, hold on. I'm just looking for integer solutions. So when x is 4, y would be 9. When x is 8, y would be 6. And so on. I skipped over the ones that would not give integer solutions. So how many have exactly 3 edges meet? And therefore, of the answer choices, the only one that appears is the 8. So the answer is D. The line segment formed by A12 and B33 is rotated to the line segment formed by A'31 and B'43 about the point PRS. What is the absolute value of R minus S? Let's make a diagram first and then try to understand this question. So here is our coordinate axes. And what are we doing here? 1, 2, 3, 4. 1, 2, 3, 4. And this is x and this is y. So here we go. First, let's plot the A, which is 1, 2. So here's A. And B, which would be 3, 3. So that's this guy. 3, 3 is here approximately. So there is the first line. Well, the first two basically points. There we go. And then the other ones are 3, 1. So let me just use a different color. 3, 1 and 4, 3. So 4, 3 is here. And that's the other guy. So that's A prime and B prime. And then there's some point P, which they don't tell me where, that apparently this line rotates around. Rotates about. Okay. Okay, I don't know where that P is. But the approach, I think, to this question is, in order to figure out this, we have to find the intersection of the perpendicular bisectors of the two connecting points. So let me explain that. So what really we're looking at is the bisector of A prime and B prime, like that. So A prime, that line, well, you know the point, so you can easily figure out the equation of the line, and I'll let you guys do that. I mean, that's just, you've done that a million times. And that's the equation. And then B prime, well, that's even easier. That line is just basically a straight line that's parallel to the x-axis, so it's just y equals 3. So the perpendicular this is perpendicular bisector. Perpendicular bisector of AA will be cutting through right here, and the perpendicular bisector of BB that's going to be cutting through right here. So let me just draw in those two lines first, and then hopefully you'll understand the question a little bit better. So we got the perpendicular bisector of this guy, which is essentially just straight up, right? Yeah, straight up like that, as long as it's perpendicular. And then the perpendicular bisector of the other guy, that might be a little trickier. Hold on, I have to draw it straight up, as long as it's perpendicular. Yeah, something like that. Okay, that's pretty good actually. So this is a right angle right here, and this is a right angle right there. So we have to figure out the equations of those two lines, and the intersection of those two lines, that, which is approximately there, that is the P. Aha, so finally it made sense. Okay, so let's first figure out this guy. Well, the slope of that line is minus a half from this guy, so the slope of the perpendicular would be 2 since it's a negative reciprocal. And we know it runs through the midpoint of A and A prime, which you can easily calculate is 2, 1.5. And therefore, you can easily then figure out the equation. And when you do, it will be y is equal to 2x minus 5 over 2. Okay. And similarly for this guy, the slope is, well, it's straight up and down, actually. So that is actually even easier because it would just be an x equals something, and it would equal the midpoint of b and b prime, which I think is 3.5, right? B and b prime? Yeah, 3.5. So there you go. So to get the intersection, we just take that and equate them. So y is equal to 2x minus 5 over 2. Well, x is equal to 3.5, so substitute that in. And then this would be what? 7 minus 2.5 is 4.5. So there you go. The peak RS is basically R is 3.5, and the S is 4.5. And therefore this absolute value of R minus S would be the absolute value of 4.5 minus 3.5, and that is equal to 1. And therefore the answer is E. Each square in a 3x3 grid of squares is colored red, white, blue, or green, so that every 2x2 square contains one square of each color. One such coloring is shown on the right below. How many different colorings are possible? All right, so let's talk about this with a basic diagram. So what we're going to do is we're going to concentrate on the middle guy. There's 4, right? 4 colors. So the middle guy has 4 possibilities. We're going to start there. And then the question says that any 2x2 square has to have all 4. So, for example, we had red, white, blue, and green, right? So the middle one, we can choose any of those 4. Let's say I choose red. Once I choose one color, for the corner, I've only got 3 choices left, these 3 guys. Let's say I chose white for the corner. Then for this guy here, I've got only 2 choices left, B and G. And then once that's selected, I've only got 1 choice left there. Got it? So that's fairly straightforward. But then what about the other guys that I haven't talked about? Well, let's think about it. That's all done. Now we've got to concentrate on another 2x2 square. Now let's concentrate on this 2x2 square, this one. Again, with a red, W, B, and G. Well, we had talked about how we put red in the middle, right? So then for this corner guy, I've got 3 choices. So let's say I chose W. Yeah. And then once that happens, everything else becomes 1, 1, 1. And that I have to illustrate why. I think you guys understood everything until the 1, 1, 1, 1, correct? And then now I have to explain why. Really have to concentrate on this 3. So I'll give a real example. So let's say we had, let me draw some of them. So we've got this guy, and this guy. Okay, so let's just go back and fill this all in. And it doesn't really matter what color you choose. Let's just put whatever, W here, B here, R here and green here. It doesn't matter. So W, R, B, G, B, R, W, G, right? They're all the same. But now I have to show how do I fill in the other ones. Now the other ones, let's talk about it. So in this 2x2 circle, the 2x2 square I should say, we want the corner 1 to be selected, and we want the other 3 to be selected in a way that all 4 colors are in that 2x2. So let's say I put R here. Okay, I could put G here, and I could B here. I can't put a W because W is already in it. Now let's fill in the other ones. If R goes there, then this has got to be a G, and then by default that's got to be a B. This has to be a B, and by default that has to be an R. You can't, yeah. And I know you immediately probably think, what if you switch these around? If you switch these around, it's not going to work, and I encourage you to try to do that, because if you put the G here and the B here, and then there you would have to put a G here, but the G's already there. So I encourage you to do that to see how that's the only way to make it work. And similarly, if the G goes in the corner, the only way to make this work would be the G, B, B, R, that type of scenario. And similarly, if you put a B in the corner there, the only way to make this work is to put a B, G, B, and R. So for each of these 2x2, there's 3. So that's why that is a 3, and then the rest are just 1, 1, 1, because there's only one possibility. So the total would be that 4 in the middle times the 3 in the corner times the 2 times the final 3, and 4 times 3 times 2 times 3 is 72, and therefore the answer would be D.